going to use the second option, the second method that I used in a previous video for this one. Since we only have a variable and an exponent when it's applied to a base of 3, I'm going to take the base 3 logarithm of both sides. I can do that because y equals log of x base 3 is a function. So if the inputs are equal, then the outputs must also be equal. On the left-hand side, those are just going to cancel, and I have 3x equals the log of 12 in base 3. To get x alone, I could say that I'm dividing both sides by 3, but it's going to be easier to type into the calculator if I write that as 1/3 times log of 12 in base 3. Applying the change of base formula. The way I'm going to have to put this into the calculator is with multiplication that's in the denominator inside parentheses. I'll get you the decimal approximation here in a moment. I'm coming up with approximately, when we round it to 4 places, 0.7540, and in a moment I'll show you how to type that in on the TI-30. All right, we've got to put in the natural log of 12. Close the parentheses after the 12, divided by, put parentheses around the multiplication in the denominator, 3 times natural log of 3, parentheses to close the logarithm, and to close the multiplication in the denominator. We're supposed to go to 4 places after the decimal point, the 10,000th place. After that is a 5. It's going to round up that 9 to 10, carrying that over 0.7540 as previously written. And if we check that, 3 to the power of 3 times 0.7540, we should come up with something really close to 12. If we were to round to the same number of places, we would have 12.0019. That's pretty close to the 12.